In this video, we're going to take a look at how you can use Pixie to automatically capture the messages between the various services in your Kubernetes cluster. Pixie, which you can install as part of New Relic's Kubernetes integration, uses eBPF technology to perform automatic message tracing. Because it uses eBPF, no code changes or app redeployments are required, and the approach is language and framework agnostic, so you get high visibility into the traffic on your cluster. With this approach, the protocols that are supported include HTTP, gRPC, databases like MySQL and Postgres, and message buses like Kafka. Most recently, support has been added for AMQP, which is used by the popular message bus RabbitMQ. And this list of protocols is growing. In addition to tracing these protocols on clear text connections, encrypted channels are supported as well. So long as the traffic is going over OpenSSL or Golang's TLS library, all these protocols are also supported. Most recently, support has been added for Node.js's use of OpenSSL, which is a special case because Node.js uses OpenSSL in a different way than most applications. Taking a look under the hood, the approach to message tracing with eBPF that Pixie uses is to put eBPF probes in the Linux kernel on the send, receive, and other networking-related syscalls that the application will make. This is why the approach is language and framework agnostic. Any traffic that is sent or received is caught by these eBPF probes, and the raw data is sent to the Pixie Edge module, where the traffic is classified and then parsed into structured events. Let's take a look at this in action. Here I am in New Relic. We'll go ahead to the Kubernetes page and into the cluster that I have running. Here we get an overview of what's happening in our Kubernetes cluster. I'm going to switch to the live debugging with Pixie tab. Here what we see off the bat is an automatic service map of what's happening inside the cluster. This is possible because Pixie is automatically tracing the HTTP traffic in the entire cluster. If we zoom in here a little bit, we can see, for example, that there's a sock shop application running where a load test is communicating with a front-end service. The front-end service is then communicating with a variety of other services. If we hover over the edge here, what we see is the automatic tracing is able to give us a wealth of information. We are able to see the throughput on this connection. We're also able to see the error rate, which is the number of HTTP response codes that are 4XX or 5XX. Moreover, we're able to see a latency profile so that we can see whether the latencies are acceptable to us or not. In this case, we are seeing a fairly high error rate, so that's definitely something to look into further. We can also switch the view here in the script pane. We can switch, for example, to the px HTTP data script. This gives us a bit more insight to what's actually happening. Here we see individual requests, the source pod and the destination pod. And for each one of these requests, we can see the latency, we can see the request path and the request method, and a bunch of other information. So, for example, if I click on this particular line here, we can see the full body of the request and response. So we see here a response body from the HTTP response. We see the first name, last name, ID, and whatever else was in that JSON response coming back to the source pod. This is not restricted to HTTP, as we mentioned. You can switch to other protocols as well. Here I'm showing MySQL data, and we can see that the actual query to the database was automatically captured as well. And so we can see that the catalog service is communicating with the catalog DB pod and sending a SQL query. In summary, New Relic with Pixie eBPF technology can be used to get automatic message tracing within your cluster, and this can be valuable when you're trying to troubleshoot your application and figure out what's going wrong, why performance is not where it should be, or you're seeing functional issues.